back in the last
It's literally a chili pepper.
That's number 1. Okay, number 3. I guess Isaac. What's the central angle that goes with arc ML?
Is it number 1?
Angle 1?
Yeah.
Yeah.
Yeah. Do your little dancing dance.
That's going on my academic.
Alright. If an angle is given, name the arc that it makes. If an arc is given, name its central angle. So it's kind of like 1 and 3, but I don't know. So on number 5, Kyle says arc RS. So what's the central angle that goes with arc RS?
Q.
Yeah, let's go ahead and call it angle RQS. But technically, since there's only one angle in there, you could call it angle Q.
Got it right, Kyle. Oh my gosh.
Alright, Xander, angle KQL goes with what arc?
JK.
No,
It doesn't? Wait.
KQL.
Oh, KO. I thought it was KJ.
You just want to say JK.
You literally suck. Isaac,
Oh, I didn't
you suck.
Your dog will be mine.
Number 9. Find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actually diameters. Alright, on 9, Craig, what would that question mark angle be? Well, the central angles, those angles in the middle, are equal to the arcs that they have. So what arc goes with that angle? See how that angle is pointing down to the bottom of the circle where the question mark is? Yeah, but the angle goes down. So this is its arc. Yeah, so it's
How is it 100?
I thought you divided by 2 because like the bottom.
No, when do you divide by 2?
That's inscribed.
Inscribed angles.
Why is it 120 and like not 155? Or 360?
The question mark is on the bottom angle, so it's on the bottom arc.
Oh.
So what does that mean?
I thought it was just
The angle is equal to the arc it intercepts.
Oh.
Central angles.
Yeah.
This one. I'm losing faith in your ability to do this test.
What?
You said, I think I'm going to do well on this test.
Yeah, I'm losing. Well, I thought I had it because I was actually thinking about it last night when my mom was yelling at me.
Were you actually thinking about it last night?
Yeah,
Like actually?
like actually.
Okay, Natalie, measurement of arc CFD. Yeah, CFD is almost the entire circle. It's major, but that's not what we're supposed to write the degrees. That makes CFD. This one is actually pretty hard now that I look at it.
Why did you give to me then?
Fun? You didn't want a hard one?
No.
Well, gotta try some tricks. So, you guys see that 135 degree angle on the left? What should that match on the right? I wish they put a letter in there.
81.
The
81 and the other one to the right.
Right. They should have put a central letter in there. Let's say the center point is M for middle. Okay. So if FMB is 135 degrees, then EMC is 135 degrees. You guys see what I'm looking at? If FMB, F middle B, is 135 degrees, then E middle C is 135. How did I know that, though?
They're vertical.
They're vertical angles. They're vertical angles, yes. If I can draw a straight line, maybe. Yeah, it's something like this. This is 135. So if, so many lines. If this is 81, and this whole thing is 135, just like this is, then how do I find this guy right here? Hang on. Yeah. 135, 81 plus this should add up to 135. So 135 minus 81, what's that, 54? That's not the answer though.
Don't you add them? No.
Okay. That picture doesn't look like theirs. Didn't do it very well. Basically, the question was arc CFD is like all the way from here to here.
So then you do 360 minus 50.
Right. So this arc right here, since we got 54 there, that's 54 degrees. So what's the rest of the circle?
306.
360 minus 54. The whole circle has to add up to 360. Went from easy to tricky real quick, huh? Mm-hmm. Okay, 13. What do those two little arc symbols in those angles mean?
They're equal.
Those two angles are the same. What do those two angles, because I have to add up to where they put the arcs,
160?
on number 13?
Yeah. 126, sorry.
126, yeah.
That's not-
Yeah. They're vertical angles again. The 126 and those two little angles on the top are vertical angles. So if the big angle on top is 126 and they're both equal, what must each of those little angles have to be?
54.
No.
Just
Tricky.
the two smaller angles.
Yeah.
Oh wait, the ones that are the same or the ones that are
Yeah, the
next
same.
to the 126? Okay.
Yeah, I'm
I
certain
was
the ones that are.
doing 63.
Okay.
I was doing
Let's see if I can draw this. Yeah, if these two angles together are a vertical angle with this angle, they have to be 126. Since they're the same, they're half of 126. So 126 divided by 2 makes them 63. Actually, I haven't even read the question yet. Arc EFC. I guess we didn't need to find that out. Because we're looking for the arc from here all the way to here, which includes 360 degrees, take away what?
126.
Take away the 126. So we're not including this arc, basically. So that's 126. So 360 minus 126. Number 15. Well, when they put those arc symbols in there, I assumed they were going to have to figure them out. I guess not. Solve for x. Assume the lines which appear to be diameters are diameters. Okay. Any ideas?
I mean, they're all vertical. Oh. You talking?
Yeah, I'm with Cadence. We're taking turns here. Any ideas, Cadence? This arc should be equal to what angle? This bottom angle right here. How, if that's 140, what's this gotta be? Yeah. These two angles make a straight line. Do you guys see it? So they have to add up to 180. So 180 minus, that's a 140, minus 140 is 40. So, Cadence, what will the equation be to solve for x here? Yeah. That's all I wanted was x, right? Yeah.
Yeah.
Okey smoky. On 16, do you guys know what those two angles have to be
180.
in the middle?
90.
Yeah, the straight line makes 180, but if those, what are two congruent angles that add up to 180 have to be 90 and 90, right? So, yeah, those are 90 degrees.
So x plus 94 is equal to
93. X plus 93 equals 90, yeah. Okay, number 17. Find the measure of the arc or central angle indicated. Assume the lines, okay, blah, blah, blah. All right, so Ava,
you're doing
arc WV. This one might be tricky too.
Okay, so is okay. So wait, I don't know how to set it up.
Yeah, it's kind of something there.
Wait, so you do no.
While you think about it, I'll draw it, and then we'll see if you have any ideas. There's a couple ways you could do it. None of them are super easy. That's a pretty good circle. If I do say so myself.
Okay, look. You see how this is split now? This is split now.
Okay. Any ideas, Ava?
No.
Like, anything we can do? If this is 5x plus 10, what's this guy right here? 5x plus 10. What's the relationship between these two angles and this arc?
They're equal.
Yeah. So, do you guys see that this and this are vertical angles?
Yeah.
It's like that and that. They're vertical. They're the same. What do these two add up to, by the way? 10x plus 20. So we could call this angle right here 10x plus 20. And how is that related to this arc right here? They're equal. Yeah. 10x. This x is not the answer, but this will help us. What do we do when we have x's on both sides? No, subtract them off one side, right? Is that what you meant? Is Cadence being critical?
Yeah.
Critical
Okay, and then
cadence.
you add the 2 to the 20. It's 22, so then you divide by 11, and then that is, no wait, no, yeah, you divide by, no, you
11
divide by 2.
11's the answer.
Sorry, you divide by 2, then that's the answer.
Okay, well, actually, kind of,
That's not the answer, but you know what I mean.
it's, yeah, it's the first part of the answer. So, we're actually looking for this guy right here,
Yeah.
or arc right here, same thing, right?
So then do you plug X in for, no.
We could plug it in here, or plug it in here, or plug it in here. So, what do we know about these two angles together?
No.
Make 180.
They make 180. So I can figure out what this big angle is by plugging X in and subtract it from 180, and that will give me this.
Okay.
Or you could do the same thing with the arc, like plug X in and subtract it from 180. 10 times 11 is 110 plus 20 is 130. So if this angle is 130,
250.
this one, at least 50 for this, and 50 for the arc. 50, 50, 50. We're on a new page. Alright, this is completely different. Do you guys remember the arc length formula? Pi r squared times theta over 360 was the sector area. It's circumference times central angle over 360. Okay, so really we're just plugging the numbers in. The radius on number 1 is 9. And the central angle is 165. A lot of times when we did the circles, we left pi in the answer, but the directions say round to the nearest tenth, which probably means they want us to go ahead and plug pi in the calculator. Turn it into a decimal. Tell me what you got.
25.9.
Got the answer sheet here. Yeah, I should have got 25.9. Tenths place is the first decimal place. All right, Caleb on 20 or so 21. I don't know what I'm doing here. I kept going with my numbers. On number 3, what should we plug in?
2 times 14
Yeah,
times pi times 300 over 360.
yeah, that's it. I don't think I made you guys memorize this formula for the test, but you do have to be able to use it, that kind of thing. Like, I'll put it on the whiteboard, but I won't tell you which problem to use it on. You gotta know the arc length formula.
Pretty epic crap.
Well, if it asks for the length of the arc, that's when you use it. If it asks for the measure of the arc, that's when you do the degrees thing from, the page we just did.
Is it actually?
What?
Yeah. Because like when you use the arc,
So there's the measurement of the arc, like how many degrees it is, and then there's the arc length, which is like how many feet it is. It's really two different types of measurements, but okay. So number 5, 2 times 7 times pi times 300 number 5 should be exactly half as big as number 3. You guys know how I do that?
Bless you.
Bless you. $3.15.